The promise of the red planet, why we must colonize Mars. The fourth planet from the Sun, Mars, has always captivated people's imaginations. Mars has long been viewed as an alluring location for research and potential habitation due to its striking red color and rough terrain. The idea of establishing a human settlement on Mars has grown more feasible as our awareness of the red planet and our understanding of its geology, climate, and resources has increased. With multiple expeditions to the planet by space organizations throughout the world, technological advancements have recently pushed us closer to the goal of human habitation on Mars. Mars investigation and research could increase our knowledge of the solar system and the cosmos and offer important new information about the beginnings and evolution of life. The colonization of Mars is a challenge that has great promise for the future of humanity, with the potential to support human existence and to open up new vistas for exploration and discovery. This essay will examine the motivations for and potential advantages of the ambitious goal of establishing human habitation on Mars. Our fascination with Mars, the fourth planet from the Sun, as a potential future home for humanity has long been strong. The idea of terraforming Mars, or altering the planet's climate to make it more habitable for human existence, has gained popularity due to Mars' proximity to Earth and the recent discovery of water on the planet. We'll look at the science of terraforming Mars in this video, along with the steps necessary to make it a reality. Recognizing the Martian terrain. The red color of Mars, which is the fourth planet from the Sun, is due to soil-borne iron oxide, or rust. The atmosphere of Mars, which is thin and mostly made of carbon dioxide with traces of nitrogen and argon, is unfriendly to life for humans. The atmosphere is not thick enough to keep heat in or block damaging solar radiation. With temperatures ranging from -125 degrees Celsius at the highest elevations to -73 degrees Celsius in the equator, the surface of Mars is arid and frigid. Mars' typical temperature of -63 degrees Celsius makes it uninhabitable for human life. Mars' lack of a magnetic field also leaves it vulnerable to dangerous solar and cosmic radiation. Knowing Mars' current environment is essential to figuring out what modifications would be required to make the planet habitable for human existence. Mars terraforming. In order to make Mars more conducive for human life, the planet must be terraformed. In order to raise the temperature and make the atmosphere thicker, which would retain heat and shield against damaging radiation, this would necessitate the release of greenhouse gases into the environment. Additionally, modifications to Mars' surface would be necessary to make liquid water available for cultivation and human settlement. This might be accomplished in a number of ways, for as by melting the ice caps to form oceans or by introducing plants to produce oxygen and give the atmosphere a more earthly feel. The difficulties in terraforming Mars. A number of substantial obstacles must be overcome in order to successfully terraform Mars, including the expense and viability of bringing supplies and equipment there as well as building a self-sustaining colony. It is challenging to maintain a thicker atmosphere and provide protection from hazardous radiation on Mars since the planet lacks a powerful magnetic field. It is challenging to forecast the effects of terraforming the planet because there is still much about Mars that we don't know, including the internal composition and the size of its water supplies. It will need a tremendous commitment of time, money, and talent to overcome these obstacles. The moral issues affecting Mars terraforming. The ethical implications of terraforming Mars are numerous, including the effects it might have on any potential native life on the planet and the long-term effects of changing another planet. Additionally, the resources needed to terraform Mars could be better used to tackle the urgent problems facing our own planet, such as poverty and climate change. As we continue to investigate the prospect of terraforming Mars, it is crucial to take these ethical issues into account. Future of Mars terraforming. The investigation of terraforming Mars is a fascinating field of study, despite the difficulties and ethical issues involved. It's plausible that we could eventually construct a self-sustaining human colony on Mars as technology develops and our knowledge of the planet increases. Terraforming Mars is a step toward a time when people can live and prosper outside of Earth because of its potential advantages. Ultimately, our decision to terraform Mars will be influenced by a number of variables, including the associated costs, technological viability, and ethical issues. Whatever the result, the investigation into terraforming Mars will continue to push the envelope of what is feasible and advance our understanding of the universe. Liquid water for agriculture and habitation. On Mars, agriculture and human settlement are both dependent on liquid water. Since liquid water serves as a source of hydration and is required for crop growth, its presence is essential for sustaining human life as well as supporting agriculture. On Earth, water is plentiful and accessible for these uses, but on Mars, the lack of a strong magnetic field and atmosphere makes it challenging to keep liquid water on the surface. The release of greenhouse gases into the atmosphere to raise the temperature and produce a thicker, more dense atmosphere that would retain heat is one solution that has been suggested for this problem. The ice caps on Mars would melt as a result, forming oceans that would serve as a source of liquid water for cultivation and human settlement. Utilizing the already existing ice deposits, which are anticipated to be plentiful on the planet, is another option. Water for habitation and cultivation might be extracted from the ice by mining and melting it. By releasing water into the atmosphere, which might help thicken the atmosphere and raise temperature, this would also contribute to the creation of a more Earth-like environment. A potential supply of liquid water for habitation and cultivation on Mars is the subsurface water that already exists. It is thought that there are significant water deposits beneath the surface of Mars since scientists have found signs of subsurface water ice on the planet. Drilling and other extraction techniques could be utilized to reach and use this subsurface water for human needs. Because it would offer a source of water that is shielded from the hostile Martian climate, which would otherwise make it difficult to keep liquid water on the surface, the presence of underground water on Mars is important. As the water could be used for hydration, agriculture, and other necessities, it would be simpler to develop a self-sustaining community on Mars. Because the drilling tools and methods needed would have to be specially made for the harsh Martian environment, accessing subsurface water on Mars would still take a large commitment of time, money, and expertise. The likelihood of making Mars habitable for human life has increased with the finding of underground water on the planet, making terraforming Mars a more attractive option. Whatever the manner, finding a liquid water source on Mars will be essential to making the planet habitable for human existence and making it possible to start a self-sustaining colony. There are many resources on Mars that could be used and settled by humans. Among these resources are water. Subsurface water and ice deposits make up a large portion of the water on Mars. This water could be used for agriculture, hydration, and other necessities of human life. Minerals, iron, aluminium, silicon, and other materials that could be used in building and manufacturing are abundant on Mars. Solar power. Mars is a good candidate for the usage of solar power due to its suitable environment and constant sunlight. This might offer a sustainable supply of energy for the world's cities. Nitrogen. The thin, nitrogen-rich atmosphere of Mars might be captured and used as a source of fertilizer for farming. Helium-3. Helium-3, a rare isotope with potential for use as fusion reactor fuel, is thought to exist in deposits on Mars. This might offer a plentiful and clean source of energy for Martian settlements. Methane. Although Mars' atmosphere is very thin, methane has been found there and could be utilized as a fuel for warmth and propulsion. Carbon dioxide. Carbon dioxide, which makes up the majority of the Martian atmosphere, might be captured and used for a variety of purposes, including manufacturing oxygen, heating the planet, and producing fuel using the Sabatier process. Materials. The surface of Mars is diverse, with some places covered in basaltic rock that might be used to make building materials and others with unusual minerals that could be used in industry and research. Mars offers a rare opportunity to investigate the geology and history of the red planet as well as potential habitats for past or current microbial life, making it a desirable location for scientific research. The findings of this study may have profound effects on how we perceive the solar system and the cosmos as a whole. Mars is strategically positioned in the solar system, close to both the asteroid belt and the outer solar system, making it a potentially useful hub for upcoming space exploration and trade. These resources have the potential to increase the viability and independence of human habitation on Mars. By making use of these resources, people may start independent colonies and eventually terraform the planet to make it more hospitable for life. Because Mars might someday act as a resource base for future trips to other areas of the solar system, the use of these resources would likewise have profound effects on space exploration and commerce. Mars travel could take just 3 months. The launch vehicle, the spacecraft's route, and the relative positions of Earth and Mars in their orbits are some of the variables that affect how long it takes to travel to Mars. It takes between 6 and 8 months to travel from Earth to Mars on average. However, by launching during favorable launch windows, such as when Earth and Mars are close to one another, the speed at which a spacecraft may reach Mars can be significantly improved. A spacecraft can reach Mars during these times in as little as 3 months. The type of propulsion system employed affects the spacecraft's speed as well. Chemical propulsion systems are now used by the majority of Mars-bound spacecraft because they offer sufficient speed and dependability for interplanetary journeys. But as new propulsion methods, such nuclear electric propulsion, are developed, the distance to Mars might be covered far more quickly. It is crucial to remember that, despite the fact that getting to Mars can be accomplished much more quickly, doing so still presents a significant engineering challenge and necessitates the development of cutting-edge technologies to guarantee the security and dependability of the spacecraft and its crew. There isn't any conclusive proof that there has ever been life on Mars. Scientists are still looking for evidence of life on the red planet, but there is compelling evidence that Mars may have once had conditions favorable for producing life. Previous Mars missions have found evidence of liquid water on the planet's surface as well as clues to a warmer, wetter past, raising the possibility that Mars once supported the possibility of life. A further indication that life may have been on Mars at some point in its past comes from recent findings of organic compounds there. Despite these fascinating discoveries, there is still much to learn about the search for life on Mars. Future missions to Mars will probably continue to investigate the planet in search of past and current indications of life and will likely offer fresh perspectives on the potential for life in the solar system and beyond. Man should colonize Mars for the following reasons. Mars exploration is a rare opportunity to gain insight into the development of our solar system's history and to look for evidence of past or present life on the red planet. Mars provides a special environment for scientific study, with the potential to increase our knowledge of geology, planetary science, and astrobiology. Utilization of resources, water, carbon dioxide, and methane are just a few of the resources on Mars that may be made available to humans for use as fuel, building materials, and agriculture. Backup plan: in the event of catastrophic occurrences on Earth, such as natural disasters, pandemics, or environmental deterioration, colonizing Mars offers humanity a backup plan. Technological developments: the goal of establishing a permanent human presence on Mars drives technological developments in propulsion, life support systems, and materials science, which have the potential to have significant positive effects on humanity. Economic gains: the colonization of Mars has the potential to open up new business ventures and sectors, such as space travel, resource exploitation, and scholarly study. Inspiration and unity: the drive to settle humans on Mars has the ability to uplift and bring people together on a global scale, promoting a sense of cohesion and purpose. Environmental restoration: terraforming Mars offers the chance to repair an ecosystem that has been destroyed and offers a special chance to research the causes and effects of planetary-scale environmental change. A better understanding of climate change is possible thanks to Mars' distinctive geology and climate, which may be studied to learn more about the stability of planetary habitats and the more general processes behind climate change. The quest for human settlement on Mars serves as inspiration for the next generation, encouraging them to seek jobs in STEM industries and come up with creative solutions to the world's problems. Expanding human presence in space. Setting up a permanent human presence on Mars will pave the way for future human expansion into the larger solar system and beyond, creating new horizons for exploration and research. Increased worldwide cooperation. The mission to colonize Mars will involve international cooperation and collaboration, which will promote better relations and cooperation between people of different nationalities and cultural backgrounds. Reducing overpopulation. With the world's population continuing to rise, populating Mars offers a new frontier for human expansion and may aid in reducing Earth's overpopulation. In conclusion, there are many strong reasons to colonize Mars, which emphasize the need of ongoing research and development in this field. The quest for human settlement on Mars is an exciting and difficult new frontier for research and discovery that holds great promise for the future of humanity. These justifications emphasize the relevance and possible advantages of human settlement on Mars as well as the necessity of ongoing funding and innovation in this field. Finally, the notion of humankind exploring and eventually terraforming Mars is both thrilling and difficult. Mars has a long history and a special collection of resources that could support human existence and further our understanding of the cosmos. The ambition of establishing a permanent human presence on Mars is now more feasible than ever thanks to technological advancements and a growing body of knowledge about the red planet. The future of humanity is greatly enhanced by the lengthy and difficult trek to Mars. The establishment of self-sufficient colonies on Mars may open up new vistas for human growth and present a chance to expand human presence throughout the solar system. Additionally, the exploration and research of Mars may shed light on how the solar system formed and the potential for extraterrestrial life. An intriguing and challenging aim that calls for the cooperation of researchers, engineers, and decision-makers from all across the world is the pursuit of human habitation on Mars. We have the chance to bring the idea of human settlement on Mars to life and open up new horizons for human exploration and discovery with ongoing investment and innovation.